You know, every single day we walk over this hidden world, a super complex, totally invisible network of pipes and cables that, well, it powers our entire lives. We're talking water, gas, electricity, the internet, the whole shebang. But what happens when we need to dig into the earth? I mean, how do we avoid slicing right through one of those critical arteries? Well, that's exactly what we're going to uncover.
Think about it, one wrong move with a backhoe, and things can get really bad really fast. We're talking massive power outages, floods, or even worse. And that's why, before a single shovel hits the dirt, a special kind of detective gets called in. Their whole job? To map this invisible world. Their mission is to make the unseen seen.
So, how in the world do they pull that off? I mean, really, how do you make a trustworthy map of something you literally can't see? Something that's buried under feet of dirt, concrete, and asphalt? That is the big question we're digging into today.
All right, so we're going to break this down and follow a utility locator's mission through 4 key stages. First up, before the first shovel. Then we'll get into decoding the underground. After that, it's all about making the invisible visible, and we'll wrap up with the blueprint for safety. Okay, so our story actually starts not with some super high-tech gadget, but with the real pro, the utility locator. And let me tell you, their job is part science, part art, and it is absolutely crucial for keeping us all safe. This is where the real detective work begins. So before they even think about turning on any equipment, the locator is on site, scouring the area for clues. They're digging into records, looking at as-built plans to get a basic idea of what's supposed to be down there. But, just as important is a good old-fashioned visual inspection. They're looking for those physical giveaways, the access points like poles, valves, and meters. These are basically the tips of that massive underground iceberg. All right, so once that initial detective work is done, it's time to switch gears. We're moving from boots-on-the-ground investigation to, believe it or not, physics. The big challenge is, how do you find a metal pipe or cable without actually digging? The solution is pretty amazing. You harness an invisible force. Okay, so it all comes down to this really cool principle. When a current flows through a wire, it creates a magnetic field around it. Simple enough, right? But here's the clever part. The reverse is also true. A changing magnetic field can actually create a current in a nearby wire. And that principle, electromagnetic induction, well, that's the magic key that unlocks the whole underground world. It lets a locator send a signal down from the surface and then listen for the echo coming back from a buried line. Now, a locator actually works with 2 different kinds of signals. First, you've got passive signals. These are signals that are just already there. Think currents from live power cables or even radio waves that are bouncing off buried pipes. They're great for doing a quick sweep of an area just to see if anything is down there. But if you need to trace one specific line, that's when you need an active signal. This is when you deliberately put on that line yourself. That's how you go from just generally locating to positively identifying.
So, how do you apply that active signal? Well, there are a few ways, and there's definitely a clear hierarchy of what's best. The gold standard is called direct connection. It's exactly what it sounds like. You physically clip your transmitter right onto the pipe or cable. That gives you the absolute cleanest, strongest signal. If you can't do that, the next best thing is an induction clamp. And then the last resort is broadcast induction. Honestly, that's kind of like shouting into a super crowded room and just hoping the one person you're looking for hears you. It can work, but yeah, it can get messy. And here it is. This is the toolkit that makes all this magic happen. This is the 3M Dyntel system. You've basically got 2 main parts. The transmitter, that's the box that creates and sends the signal, and then this handheld receiver, which is what the locator uses to actually detect that magnetic field and trace its path. This is the really sophisticated gear that translates those invisible fields into a super precise location on the ground. And look, this isn't just theory. The pros out in the field rely on this kind of tech every single day. I saw a great comment from a user on a professional forum, and he said, in those really congested areas, where you've got TV, phone, electric, and gas lines all tangled up together, this kind of equipment lets you find almost anything. And that's exactly the kind of confidence you need when the stakes are this high. All right, so the locator has found the path of the utility. Awesome. But the mission is not over yet, not by a long shot. The science part is done, but now comes a totally different challenge. They have to communicate that information clearly, accurately, and in a way that everyone on the excavation crew can understand. And the solution is, well, it's surprisingly simple, but also kind of brilliant. It's a universal language of color. Using special paint, or sometimes flags or stakes, the locator marks the ground directly above the buried line, and each one of those colors tells the digging crew exactly what they're about to run into. And this isn't just random. This color language is standardized by the American Public Works Association. So for instance, red, that's for electric, yellow is for gas, oil, or steam. Orange means communications, like your phone or fiber optic cable. Blue is for potable water. It goes on and on. Even white has a specific meaning. That's used to mark out the proposed area of the digging. So seriously, the next time you see these spray-painted lines on the sidewalk, you'll be in on the secret. You'll know exactly what's going on.
And just like any language, there's a grammar to it. The rules are super precise. These marks have to be placed at least every 3 meters and also at every single bend or change in direction. The whole point is to lay out the entire path of that utility so there is absolutely no room for guesswork. But wait, the paint on the ground? That's really only half the story. All of it has to be backed up by some seriously meticulous paperwork. This here is the primary locate sheet. Think of it as a super comprehensive report that captures literally everything about the job. Who asked for it, where it is, what was found, and, critically, any warnings for the excavator. And that's followed by this, the auxiliary locate sheet. Now, the most important part of this sheet, by far, is the sketch. The locator actually hand draws a map of the site. They show exactly where their markings are in relation to things that don't move, like buildings and curbs. It's literally the paper version of the map they just painted on the ground, and it even has a legend to define all the symbols. So you put these documents together and you get the official locate report. And believe me, this is way more than just a piece of paper. It's a procedural and legal record that becomes the absolute blueprint for safe digging. It's what ensures every single person on that job site is on the same page and understands what's underground and exactly where it is. So, okay, we've seen the skill of the locator and the science behind the equipment, but what's the glue that holds all of this together? Well, it's a really rigorous system of standards, training, and procedures, all designed to make this whole process as safe and as accurate as humanly possible. You see, a locate isn't valid forever. Before a crew can actually start digging, a bunch of conditions have to be met. The marks on the ground have to perfectly match the sketch in that report. Check. The report has to come from an authorized party. Check. And here's a big one. The locate is only valid for a limited amount of time, and only if the site conditions haven't changed. So for example, if someone else digs a new trench nearby after the locate is done, the whole thing could be invalid. And it goes without saying, the people doing this work are seriously well trained. This isn't a job you can just, pick up over a weekend. Locators get documented training on the fundamental theory, on specific techniques for all kinds of different conditions, and of course, on extensive safety procedures. It really is a true blend of book smarts and hands-on skill. Because at the end of the day, this is what it's all about. Every single step in this process, from digging through old plans to drawing that final sketch, it's all laser-focused on one simple, vital goal: digging safely. It's all about preventing damage, avoiding injuries, and keeping that invisible network that powers all of our lives completely intact. So the next time you're walking down the street and you see those colorful lines painted on the pavement, you'll know they're not just some random graffiti. They're actually the final chapter of a pretty incredible story. A story of detective work, of applied physics, and of a universal language, all working together to map that invisible world that's right there, just beneath your feet.